Um, yeah, thanks everybody, and glad to be here. Be covering Calico Enterprise in action. This is what I look like. I'm actually a channel account manager from Tigera, and I'll be doing just a quick introduction on Tigera. First of all, we are the company that actually invented and maintains Project Calico, which is the most adopted open source Kubernetes networking and network policy solution mainly. There's a couple of reasons for that. Calico is actually the first CNI to pioneer the idea of doing non-encapsulated routing in Kubernetes, which is probably now the most popular way of doing your networking, both on-premise and all the public cloud providers also do it that way as well. The other thing interesting, and I think Mamta's session covered network policy earlier, Kubernetes network policy, is that Kubernetes, you can define network policy, but it actually doesn't do anything until you actually have a CNI like Calico that actually implements or enforces the actual policy. And so Calico was actually the first CNI to actually come out with network policy. In fact, we had policy before Kubernetes created the definition for network policy. So Kubernetes actually referred to Calico's policy to come up with the idea of network policy. So it's used pretty widely across the world in a lot of Kubernetes deployments today. Over time, though, Tigera as a company, we were originally providing more like support and customization for Project Calico, but we did come across quite a few customers that were moving into production, and then they came up with additional kind of security and compliance requirements for their network that we felt it was best solved by creating a separate product, which we call Calico Enterprise, and that's what we focus on today. So while there are maybe thousands of customers using people using Calico out there today, these are just some of our commercial clients that you would say fall into areas like financially regulated organizations, telcos, large technology companies, manufacturing, insurance, and pharmaceutical, for example. Along the way, as both as an open source project and as a commercial project, we have built up partnerships with many of the cloud providers today. In fact, many of them use Calico as a default network policy or even the default networking, both on-premise and in the clouds. So you can see in both in Kubernetes on a cloud platform, as well as their managed Kubernetes platforms like EKS, AKS, GKE, IKS. And then we have Rancher and OpenShift for the on-premise Kubernetes distros, Kubernetes D2IQ. And we also have a kind of interesting partnership with Fortinet, which is more of a network security provider because they don't actually have a solution for Kubernetes network security. So they actually recommend us to customers where they have that requirement. So let me just cover here a bit about the use cases that our commercial clients were looking at when they were trying to go into production with Kubernetes. So if you remember the session from Mamta earlier about network policy, we have to remember that the initial Kubernetes networking is, you could consider it insecure because basically every pod in every node can talk to everything else in the cluster. It's a default allow model. And so you did need some form of network policy to be able to block access from, let's say, pod A to pod B. And you don't want all the pods to talk to each other. That's a really bad thing from a security perspective. So Calico would be used there for network policy. The other thing, though, is that Kubernetes clusters are never like standalone typically. They do need to communicate to other services. Those could be like third-party services or APIs with Salesforce or Twilio or Zora. In fact, even within the clouds, for example, you may be talking to an Amazon database service or Azure storage service. So they do need some to be able to control the communication out. A lot of deployments we're seeing are now kind of hybrid deployments as well. So you may have Kubernetes running on premise. You may also have other services running on premise. So while it's growing, not a lot of databases today are actually, or stateful services are deployed on Kubernetes. So things like your Oracle database or SQL Server databases, you do need to still connect to those services to get data, to post data, and so on. Now, how this kind of traffic would have been secured in the past is using things like firewalls or network security devices, and you may have SIEM technology to also monitor the traffic. But Kubernetes actually presented a big problem for all those traditional devices because they rely on the IP address as the identity for, in the past, it would be a virtual machine or a host. And Mamta also mentioned earlier in the session that the IP addresses are not static for a pod in Kubernetes. They keep changing every time a pod is spun up and spun down. You can't really assign a static IP to it. So what this means is that today, if let's say I put a firewall here, and then I want to say, okay, this pod should be allowed access to this database, my database. Well, basically, I would have to whitelist my entire cluster to access the database because I can't be sure which IP address you'll be using to connect. It could be using node 1's IP, the pod might move to a different node, and then I'll be using node 2's IP. And so if I wanted to allow anything within this cluster to access this service or to access an external service, I now have to allow pretty much everything access. So again, that's a really insecure way of putting up your network. The other thing is, even if those security devices detect like some kind of suspicious traffic going out, they can't actually identify which pod it's coming from because you've basically whitelisted the entire cluster. So in the event one of these pods is compromised, I might have to actually destroy my whole cluster to and rebuild the entire thing because I don't know which particular pod or service was compromised. And of course, some guys may also be doing multi-cloud type deployments where they deploy across different clouds because they don't want to get locked into a single vendor, for example. And you do want to have a way to kind of a single policy across all these different environments, because having many policies running a separate policy in each environment would be a nightmare to manage, deploy, and also troubleshoot. So to summarize, there are some challenges around not having granular ingress or egress access control with Kubernetes networking. If I want to allow something access, I have to allow everything in the cluster. Without network policy, you don't have any east-west traffic control. So if one of my pods is compromised, the attacker has a free reign to basically move and compromise everything else in the cluster as well. If I do have traditional firewalls, web application firewalls, SIEM devices, they can't understand the Kubernetes traffic, and therefore your compromises and threats are going undetected. Also, there's some visibility kind of challenges that comes with Kubernetes on the networking front. One of it being that there's really a huge increase in the volume of data, because if you think about it, you've now split up your monolithic application into many different containers. All these containers are now communicating over the network. So the amount of traffic that's flowing is actually much larger than in any traditional environment. Another thing is when you do have monitoring tools, they cannot understand Kubernetes, one, because of the IP address, two, Kubernetes does introduce new concepts that may not have been seen before. So you think about it, there's now pods, there's clusters, there's namespaces. All these things have to be rebuilt for the Kubernetes kind of era. So seeing all these issues that our customers were facing, we did build up a set of solutions that actually, of course, have to work in a multi-cluster, multi-cloud, hybrid cloud scenario, because that's the common deployment models we were seeing. And for those of you from the networking background, you'll see some familiar terms here around north-south control, east-west control, overall security compliance, and then observability. North-south control, of course, meaning traffic that's leaving the Kubernetes clusters. East-west control is talking about traffic within the cluster itself. So on the north-south front, we understand that firewalls and SIEMs will still be there. In fact, we don't replace the SIEM functionality for every deployment. So one thing we do help to do here is to actually have this concept of an egress gateway. And what we're doing there is basically source netting all the traffic from a particular pod or a namespace to a specific IP. So now if I see that traffic in my firewall or my SIEM, I can actually identify which pod or service or namespace it's coming from. Another thing we add to the base Calico network policy, which Mamta already mentioned is an extension of the Kubernetes policy, is this ability to define domain names within the policy instead of just lists of IP address. And that's because, as we know, many of the cloud services today, they don't give you a list of IP addresses to whitelist. They basically give you a domain name. And if you try to put in a list of IP addresses and the provider changes those list of IP addresses in the back end, you're going to lose connection to all your services. So we have this thing called domain name service policy, which allows you to put domain names inside the policy. And of course, we'll provide the actual egress access control on the north-south front, as well as the east-west control. And networking is typically divided into layers. So we have L3, L4, and then the L7 layer. So application layer will be considered L7. Calico is known more for providing the L3, L4, which is like TCP, TCP, UDP ports, opening and closing those ports. But we have added the ability to also apply the controls on the L7 level. So you will see information around like, can you allow a GET or a POST on the HTTP GETs or POST? We can also see request responses as well as latency for the application layer. So we do the microsegmentation for containers as well as VMs and host protection. Later, I'll show you some of the things that we have to help to manage the policy, because sometimes it's not just enough for you to kind of put a policy in place. You do need to audit it as well. You do need to define it, troubleshoot it, and we have some tools to help you do that. I do want to mention that VM and host protection is actually pretty important, because maybe if I go back to a slide here, imagine you want to allow, let's say, this pod access to this other pod here. Well, you actually also need to allow access on the VM level itself. And while you could do that with, and I think Yogesh was using like networks, was using security groups in AWS, and there's other similar concepts in Azure and other ACLs on-prem as well. The fact is you'll now have kind of two different policies to manage. So let's say I want to allow access from this pod to this pod. I have to ensure that the port is the port and protocol is also open on the node. And every time I make a change, I've got to make it change in both places. If there's an issue with the traffic, I got to figure out whether it's the pod policy blocking it or node policy. And sometimes if you put stuff in the host networking of the node, you can actually overwrite your pod policy. So that makes it all very difficult for anyone trying to administer this kind of network policy. The other thing is, let's say I want to connect to my database that sits outside of Kubernetes, not even a Kubernetes node. Well, you run into the same issue. So if I want to access this service here, I got to make sure there's a policy here that allows it or blocks the traffic. And what Calico would then allow you to do is apply a policy across the containers, the VMs or hosts that host the containers, but also to machines outside of Kubernetes as well. So that's something we would add there. And then on the security and compliance front, and I think Ravi also covered this quite a bit, and many of the organizations today have some form of compliance they have to address, whether it's PCI. SOC 2 is a bit more North America, but ISO 27001 will be the more common one for security globally. And so you will be audited against these requirements. And these requirements will generally state, hey, you do need some form of network segmentation. You do need firewalls in place. You do need some form of network intrusion detection and prevention. And you also need to do data in transit encryption. So these are things that we would help to clients to address these requirements. And also we would audit the actual use of the policy. So oftentimes it's not enough for you to actually implement the policy. You have to show the auditors that you have implemented it and that no one has made any changes to the policy over that period of time. And if they did make a change, you have to track all those changes as well. So we do provide our reports in order to show the policy or auditors that the policy has been enforced and no changes have been made. On the visibility side, we have some interesting capabilities here, being the networking part of Kubernetes typically. One of that is the ability to do packet captures. Now, packet captures are a very common tool today to actually identify like packet loss issues, even forensics for network security. The issue, though, is that traditional packet capture tools, let's say you're trying to do a TCP dump on a particular traffic from a particular pod. Well, now you need to first figure out which node the pod is sitting on, find the correct interface that you want to do a TCP dump on, and then you'll get a bunch of information that's based on IP address. And you hope that the IP address that the node is using, you have to make sure that the IP address is actually the IP address that the pod was using at that point in time. So that's all really painful for anyone trying to get those packet captures. So what we do here is basically giving you the ability to use Kubernetes, like labels or Kubernetes namespaces to pull the traffic. So I can say, oh, I just want this traffic from this particular pod name or pod deployment or a particular label, and you can pull the packet captures for that. We're actually generating all the flow logs from all the traffic that we're seeing in Kubernetes, and we can actually identify performance issues around things like DNS latency, HTTP latency, and also network latency. And we also visualize all the traffic for clients in a service graph, so they can actually see and troubleshoot things like network policy very easily. I just want to mention here again that we do have strong partnerships with many of the Kubernetes distributions today. And that's actually really important because one, although everyone says they run Kubernetes, they do change the settings and configuration for each of their distributions quite a bit. So we spend quite a lot of engineering effort just making sure we have support for the latest version of OpenShift or the latest version of EKS or AKS. And I guess being a popular kind of open source project, it's a good thing that the vendors are so willing to work with us because we do need their support as well to be able to support all their latest versions. Okay, so that's it from the slide perspective. Next part to really show you some of the tools that I was referring to. Okay, so this is a view of Calico Enterprise. So we do give you a user interface to actually manage the tools. It's a multi-cluster interface because I connect multiple different clusters to it, and you can easily switch between them to see like different views for each of your cluster. So this is just, I think, an example of a cluster running on AKS in this case. So we do give you some high-level view of the network traffic currently flowing in the cluster. We give you some information about what's happening with your policy. So it looks like there's some traffic being denied by this particular policy under the global security pass namespace. I've got a total of 49 policies, 3 are currently denying traffic. I've got 53 endpoints, and later I'll cover a bit more what endpoints mean. Note amount of hosts that are actually hosting Kubernetes pods. I've got actually a huge number of alerts happening right now because I'm actually generating them in the backend. So let's go into a view of the policies. Now, in Mamta's session, you saw that basically all the policies eventually will be converted into the YAML format so that you can deploy that in your CI/CD pipeline as part of DevSecOps and so on. The thing is, I don't know about the audience here, but no, so far, none of the developers or DevOps people we talk to really like to actually define network policy in YAML. It can get pretty complicated. It's, as Mamta mentioned, there's quite a lot of syntax to it as well around and or. And imagine you have a large clusters with lots of different applications. Policies can start to get pretty complex. So I think the fact that we do have an interface here for users to visualize and define their policy really helps to start with. And here you're seeing a new concept that we introduced in Calico Enterprise, because one thing we were seeing is that a lot of people get involved when it comes to defining policy. So we usually have a different team for security, then maybe a team for a platform, and then you want to give your application developers the ability to actually define their own policies, because they're the only ones who know what the application is actually supposed to be allowed anyway. So in order to facilitate that process, we create this concept of tiers, and these tiers can be role-based access control, and there's a priority to them. So the security tier will apply first, and then the platform tier, and then the developer tier. So if, let's say I was a developer, I might only be able to see my tier, for example. But if I was the security team, I could see perhaps all the tiers. And so what this does is it allows the security team to first go in and put in some let's say, policies that should be applied before anything else. So they can put in things like a threat feed. A threat feed would be one of our intrusion detection capabilities, basically, but it's a list of suspicious IPs that can be constantly fed in from research sources. So you can have a threat feed. We have actually built in a few like Alien Vault, which is from AT&T. It's a research service they have. There's another one called Fyodor that they find these lists of suspicious IPs, and you can basically put a block list for basically blacklisting all these IPs. And you can put in things like embargo if you don't want to communicate with certain countries. You can put in a PCI whitelist that only applies to your PCI clusters, for example. So security team can go and put in all these policies first. They can then hand it off to the next team, the platform team, and they can put in things like logging tools, integration tools. They can allow things like kubedns, because we have seen cases where developers go in and they put a policy, then they block kubedns, and then the whole cluster crashes. So the platform team can avoid that by putting these base policies in. So developers won't be in that stage where they can hang themselves. And then you can pass it on to the developer, who can then actually define the policies required for that particular application. Now, if you remember also Mamta's session, she was talking about how when you go from a default allow to a default deny model, default deny, of course, being the more secure option, it can be pretty challenging because first of all, now you got to figure out like, okay, so what actual ports and protocols and traffic does my pods or my services should be allowed. So one thing we do help here is the ability to recommend a policy. So what we're doing is here is we're actually looking at the logs from, let's say, 15 minutes ago. You can set even longer if you want to, like 1 hour, 3 hours. You can select the namespace you're interested in. Just like kube system, and then I can choose, let's say, core DNS. And I'll say, hey, recommend me a policy based on the traffic that you've been seeing over this period of time. And so we'll tell you, okay, these are the labels that you should use in your policy. Because if you remember in network policy, it's now the labels that are basically the identity, no longer the IP address of any of these pods or services. And then it'll tell you, okay, based on the traffic we're seeing, these are the ingress rules you should be allowed. So you should allow protocol UDP from endpoints with these labels and these namespaces to ports 53. And if you think that you can also simplify the rules a bit. So if you think that I should allow anything from port 53, you can change this to allow any to port 53. You can remove all these different rules. They also see a bunch of traffic from, well, I'm running an attacker app that's hitting everything on the port. So this is probably a very weird rule. But if you don't like it, you can, of course, delete it. So you can remove the rules, you can edit them, but it's a really great way for users to get started because it's kind of hard to design a network policy. You don't have any data to begin with. Okay, let's look at a specific policy here. Let's just take a look at this one. Mamta, I think, mentioned briefly that Calico policy was already an extension of Kubernetes network policy, and one of those extensions was the ability to apply a policy across all the namespaces in your cluster, because a policy is typically only namespace scoped. That's basic Kubernetes network policy. But you do have policies that you want to apply across your entire cluster, so you don't want to keep repeating the same policy across all the different namespaces. You can set it to global instead. So you can see here that it's an GUI interface, so you avoid you messing up your YAML files and then having to troubleshoot the issues later. So you can add your label selectors here. You can type them in, or you can enter them here. You can define your ingress or egress rules. If you just want to avoid using Calico extended options, you can switch this to use Kubernetes network policy. They'll remove some of the extensions that Calico provides. Okay, so if you think about like firewall rules, network policy in general, people are often afraid to kind of make any changes, because if you deny something wrongly, you're going to break your cluster. If you allow something accidentally, you might introduce a compromise into the cluster. So let me try to make a change here, and let's see how Calico Enterprise can help there. So let's say I change this rule from allow to deny. And again, deny is a rule that only Calico network policy has. Normal Kubernetes web policy is only allowed. So let's say I just change to deny and I want to save the rule. Well, before I actually enforce this change, I might want to actually preview what's going to happen in the event I make this change. So we have this preview option here. It's going to launch our flow visualizer view, and it's currently set to only changed flows. So what this means is that these are the flows that will be changed after the policy is actually enforced, right? So we're going to do some visualization to show what's going to happen here. So after I apply this policy, I want to see what's going to be denied. Well, it's telling me that after I apply this policy, attacker app to core DNS will actually be denied. So this may or may not be what I want. And if it's what I want, I can say, okay, that's fine. I can go ahead and deny the policy. If not, I can revert it. So this is a great way to check like any changes before they happen, so that you can be sure that you don't break your cluster or cause some kind of compromise before you make any changes, before you add or delete any rules in your policy. The other thing we can also do is you can put it to, if you're still not really certain and you want to see it like in a production environment for some time, you can also set the policy to stage mode. So what that will do is it'll create a copy of the policy, something like this. So staged. So there's a DMZ policy here, but it's also a staged one. And the staged one will basically put the policy into logging mode. So it won't actually enforce any of the rules, but it will log what will happen in the event that the policy was actually enforced. So over time, you can let it run for a while, and then you can come back later and take a look at the policy, and hopefully you've generated enough traffic so that you can then preview and check if there's any changes or any if you see any denied traffic that shouldn't be denied, you can go ahead and modify your rules again to make sure that that won't affect your cluster traffic in the future. So that's another thing we do to help you to kind of test out your policies before you actually enforce them in the cluster. And one more small thing we do here is, let's say you're making some changes here. So let's say I make a small change from currently thread feed equals to Fyodor. Maybe I'll change it to thread feed equals to Fyodor, which is the actual name. I save the label selector here. Okay, so save the rule. I can go back here in about a couple of seconds, but I did it earlier. So what I can do is I can do a diff on the policy change. So I can see here that it'll highlight, oh, your change was originally from Fyodor and change it to Fyodor. And if that is correct or wrong, you may want to change it back because comparing against a previous version of the file, essentially. So these are things we do to track. And like I mentioned, we're tracking all the changes happening in network policy. So you have a timeline here that you can also show all the different changes that have been updated over time. And later I'll show you also another report that you can show your auditor to say that, okay, maybe in the past 24 hours or past 1 day, there wasn't any person changing any of the policies or sets. The next part here is the endpoints. So what I want to show here is that most of the endpoints will be things like containers or basically pods in Kubernetes. And you'll see here some information on that pod, what the particular name of that pod is, the labels that's applied to the pod, and the policies that's currently applied. But you also see some other objects here, and these are actually hosts. So they're currently running the Linux operating system, and we also support Windows. But now these hosts can also be applied labels. So these labels, for example, zone equals to PCI. So now that means a host or a VM or even a non-Kubernetes machine is now a first-class citizen in your network policy. So any Kubernetes policies that you apply that reference this label, the same rules also apply to that host. So now I don't need to create like a separate security group or an ACL for that host. I can do it all within my Kubernetes policy as well. So that's really great for managing your policy, not just on the pod level, but also on the host level and to non-Kubernetes environments. You can see some node information here. Just tells you what are the IP address currently assigned to that node and the endpoints. Here's another thing or object that Calico adds to the network policy, and that's concept of network sets. So network sets are basically lists of IP addresses or CIDR ranges, and you can actually, well, in this case, it's a feed. So it's a set of CIDRs that are constantly being updated in the backend. I can apply a label to this, and then I can use this label in policy. So if I look at this policy, for example, it's telling me that it's going to deny any protocol to endpoints with the feed equals OTX IP thread feed label. And the IP address is constantly updated in the backend. So it's used for the security feature, but it's also, of course, used for people and organizations who are managing lists of IP addresses or CIDR ranges, and they don't want to keep updating the range in every single policy. They can just apply a label to it, and then they can use a label in all the different policies. So every time you just need to make a change here, and then it'll apply across all the different policies. And if you remember, I also said we could also put domain names inside the policy. So here we will see that this one is using domain name instead of IP address. And I can also edit it just to show you. So I can add more domains as well. I can say, star.s3.aws.com to allow access to AWS's storage services. And then I can save a network set and apply a label to it. So now this means that these policies that are looking for this label type equals to external API, I'm allowing any protocol to endpoint type equals to external API. So it's basically allow rule to those domains that I'm mentioning. And that's really important nowadays because most of the services you're connecting to outside will not be using this IP address. Of course, you can also change the domain directly here, but you might want to use it in a list, so you might want to apply a label to it so that you can use it in different policies as well. I mentioned that we're going to be visualizing all the traffic in your clusters in the form of a service graph we have here. Let me take a look. How to remove this bar here. Okay, so this is a view of the namespaces currently in my AKS cluster. We're showing allowed and denied traffic here. So green means the flows are being allowed, and red means there are packets being denied. And if I kind of click on one of these flows here, they actually tell me storefront is currently denying at source to public network. In our tool, it actually should also point to the policy that's actually denying the traffic, but my current service here got a bug that they were introduced like yesterday, so it's not linking to the policy. So I actually have to go here and check what actual policies are denying it. But it's a great way to troubleshoot what's happening in your cluster from a policy perspective. So I can see here that this is the policy order that's being applied. So pass, but storefront default stage trusted deny is currently blocking traffic, as well as this policy downstream as well. So if I come here, I can really see with a quick glance, oh, there's some packets being blocked at policy, and I can do something about it. We also are collecting information around like what network processes are actually generating this traffic. So I can see there's a wget process that's running on storefront that's trying to reach out to the public network. We also, in some cases, we will show you the socket stats for long-running connections. So this will just give you information around the TCP mean time, mean segment size and window size as well. So this could be useful information for troubleshooting. I mentioned that we are working not just on the L3 and L4 level, but also in the L7 level. And I can show you an example here. So within Hipster Shop, which is generating some HTTP traffic, I can switch the view to look at HTTP flows only. And I can see looks like most of it is green success, but here it is generating some red server errors. So as I click around, it also filters the logs for me. So I can actually go to the HTTP logs here, and maybe I just want to see and response code equals to 500, which is server errors. And from here, I can see, okay, it looks like it's my load generator application that's actually trying to reach the hipster shop front end. And this is the method it was using, post, and this is the URL I was trying to hit. So we're seeing a lot of these things could be something to investigate because server error is not good if you're actually sending any traffic to any application. One thing you'll see both in the HTTP logs as well as the flow logs here is that this is not your normal flow log. In the sense, the normal flow log which only consists of IP address, port, and usually won't have the action allow deny. In fact, Calico is the only one that can actually provide this allow deny information because we're the ones actually enforcing the network policy. But we also add in all the Kubernetes metadata so that you can actually understand the traffic, because an IP address would not be useful. The IP address for this pod or service will constantly be changing. So what we're doing is we're appending the actual name of the pod. Usually a pod is part of a set, like a replica set or a deployment set. And so we aggregate, but you always have this source name aggregation in front of it. So you'll still know what service it's coming from. And we'll also actually put in the label information as well. So we'll know what labels are actually being applied to this particular pod. So it's app equals to load generator is another way to identify the pod as well. So with this information, you can now be kind of cognizant of where actually the traffic is coming from, because this source IP would not be a useful indicator because it would change at any point in time. You also see some sort of like alerts happening, because we do have a separate alert, and maybe that'll bring me to some of the other capabilities around intrusion detection that we currently have. So let me just change the view here. So we were trying to come up with ways of doing network intrusion detection that really don't affect the performance of your cluster, because the traditional way of doing like deep packet inspection and matching your signatures, if you remember, the Kubernetes network traffic is orders of magnitude larger than a normal like service. So one of the ways is kind of deception technique. In security, they call it honey pots. They call it honey pot because it's Kubernetes. And so if you look at Tigera internal namespace here, we help you to create some fake pods or services, and essentially. So we have an internal app service and an internal service dashboard, and then a fake kind of MySQL service. And so we consider them fake services, which means that if for some reason someone got into your cluster and start touching these services, which is what commonly the attackers will do, they'll do like port enumeration scans. They'll try to find open connections, and so they'll end up hitting everything, and they'll usually end up hitting your honeypots as well. And so with this, though, we have a pretty high degree of certainty that something here has been compromised, because it's reaching out to pods that should never be accessed in the normal order of business. The other good thing about this concept is that one issue people have found with trying to do forensics in Kubernetes is the logs. It's just too much and keeps changing because the pods keep spinning up and down. So if you keep these kind of long-running pods that an attacker is trying to get into, at least you can keep the logs for these pods and try not to spin them up and down as a normal Kubernetes pod would. Then you would be able to try to see like what actually the attacker was doing in your environment. So, but anyway, if I try to trace back to the default namespace and see where the traffic is coming from, I can see that this conveniently named attacker app pod is the one that's actually reaching out to all the different services and trying to hit them. So with that, we can go into a dashboard that shows you another view of the honeypots running. So we're storing all these flow logs in Elastic as our backend, and we can visualize it using Kibana. So we built out a honeypot dashboard here, already set to the namespace Tigera internal, because that's where all my honeypots are sitting. And over time, I've seen two pods that have actually tried to pods or services that actually try to access these honeypots. So NetShoot as well as attacker app. And just a number of times it was attacking. So it was hitting my internal database the most, but internal app and dashboard has also been hit several times. This is a kind of heat map to show you that, yes, internal DB is the reddest and attacker app is the one that's constantly trying to access the database. And these are all the actual flow logs for that particular honeypot. So here we will see details around what kind of port. Actually, I just don't need to. You can see what kind of port it's trying to go into, 9102, the host it's sitting on, and the actual source name aggregation. Right. So this is one dashboard we have here. Another we also visualize other dashboards for use for important services, things like DNS, which is a critical service in Kubernetes because everything relies on DNS, without which none of your pods will connect. So it's currently visualizing across actually all my clusters, but it's showing me like high-level information around how many successful DNS responses and unsuccessful ones. And if you see any interesting data here, like this one has a large number of DNS external queries, I can also select this across and take a look at the specific URLs it's trying to hit. So I can see here a bunch of random kind of queue names, so kind of suspicious in terms of what DNS traffic is trying to do here. But overall, you can look at other information as well, like latency, and if you see any spikes, you can also filter the traffic to see if perhaps something is wrong with your DNS service. So it's looking at the counts, when's the most common time for it to be asking a lot of DNS queries, and also top external domains. And you can actually filter the logs yourself in Elastic as well. So DNS, another interesting dashboard might be HTTP. So looking at the HTTP logs for all my services, I can see looks like front-end service is the most popular service, but there are a number of 504, which is server error response codes. You might want to take a look into more detail on these response codes, and then look at it looks like they're mostly post requests to front end. And these are the URLs that are currently seeing these logs. And so it's post response code 302 to, here's the shot. 302 is also a problematic response code. So these are things you can use to kind of check like network flows, latency information, error messages that are coming up in your cluster. A lot of our initial Kubernetes users actually said that when they first set up the cluster, it's kind of like a black box. You don't really see any of the traffic, or even can even control any of the traffic flowing within the cluster. So this is something kind of new to them and something they're really interested in as well. The other sort of intrusion detection technique that also does not affect performance is actually we are running machine learning jobs on Calico Enterprise that will actually generate anomaly detection alerts. So what this service is doing is basically it is baselining your traffic and looking at the behavior of it over time. And if it detects like suspicious behavior, like someone doing a port scan, this one scanned 4,991 destination ports, it'll tell you it's an anomaly with a really high confidence. Like 1 is absolutely confident, 0.99 is really high. So, and then we'll tell you like which actual pod is the one that's doing this anomalous behavior. So this is another intrusion detection technique. We've got a few machine learning jobs running. Aside from port scans, we have sudden inbound, outbound spike in bytes, process restarts, DNS latency, trying to hit many different domains at the same time to mask the traffic. So those are things that we're also doing to detect intrusion detection. And again, this won't affect your performance because it's not, it's just looking at the behavior. It's not like running inline kind of, or trying to pull the traffic or matching in signatures in real time. So that's another common security technique that we're also applying to Kubernetes as well on the network intrusion side. The last piece on compliance is I mentioned that we want you to have the ability to show your auditors that you have your policy applied. So this one is basically a job that's running in the backend and always checking, like have the policies been applied across all your endpoints, your namespaces, egress, and egress namespaces. And of course, you can download all the details in the CSV file and show your auditor, because we were actually hearing of people who were like screenshotting the application to prove that they have the policies applied. But I think it's a lot better to just give them an Excel file to review. The other one is we can also show you did anyone over the past 6 hours actually make any new NL policies? Did they modify anything? Did they delete any NL policies? And it's kind of cool that Ravi showed you Kubebench, because we actually also use Kubebench just to give you, we help to run it for you. So we run Kubebench CIS benchmark on all your nodes, and we can generate a report for you. So we developed the cron job basically that's running in the backend that you can set to run like every, 1 day or 2 days. And you can generate a report on the same report that Ravi showed in his earlier demo, but in a CSV format, which might be easier for some people to consume. And yeah, the last one that I can show you here is we're actually going to put it in the interface. So in future, I would say, okay, I look at my Tigera internal namespace and I want to capture the actual packets that are flowing, so I can investigate what kind of packets are being sent by this suspicious application. I would be able to select this namespace and then do a packet capture. That's coming like next week, really. But before that, we just have to run a command line here. So I've got the command here. Just launch the folder that I'm putting it into. Delete all these existing ones. So basically, we define a YAML file that says like what kind of namespace or pod aggregation that you want to capture. And then you say, okay, capture the traffic for me and put it into my local desktop. So this will run the capture job. And you can put in additional parameters, like maybe you want like a specific protocol of a specific period of time. I'm just capturing over the past, I think default is like 1 hour. And so it pumps these pcap files into my local desktop. And I can, of course, use Wireshark to take a look at the actual packets. So I launched it in Wireshark, and I can see the actual packet traffic that's going in here. You can look at all the details around like what frames are being sent, any loss in traffic, and any interesting like URL information. It's doing that as well. So you can verify also to see like, okay, traffic still coming out in IP address, but I just want to make sure that it's correct. So 10.240.0.7. Let's take a look at some of my endpoints here. This was meant to be to the internal dashboard application. So yeah, so it's 10.0.240.4.40. Is that the same? Yeah. So something with 10.240.0.77 is sending a packet to internal dashboard. And as I said, based on the logs that I saw, it was definitely the attacker app that's doing it. So I check that here. I'll see that. Yep, it's actually this particular application pod or application or service that is sending all that suspicious packets. So I can take a look at the packets, and it's receiving, it's not responding, but it's still acknowledging that the packet was sent. So of course, in Wireshark, you can filter by protocol and other interesting data that you want to see. Yeah, so that's it from my demo.